We ready? Let's do this. Welcome to episode 16 of Things Hidden. Things Hidden is an exploration of faith and 6 factors that surround faith: religion, physics, evolution, consciousness, philosophy, and technological innovation. The purpose of Things Hidden is to bring people into a closer relationship with God, and through that process, coming into a closer relationship with God myself. Okay, here we are. Today, we will be reviewing 2 short reels and a bit of a longer clip about time. And I've included links to these clips in the description here. And time is obviously a big deal. We have talked about time at length in prior episodes. And today we're going to be unpacking some of those comments in further detail, specifically going back to some of the things that we talked about in episode 6 on physics. So I'll just start things off with just sharing a couple minutes from that episode 6.
It is also crazy because it's sort of not real. And admittedly, that's a bit of a misnomer saying that time isn't real. But it's a statement that's easier to comprehend than saying time is emergent, not fundamental. It's easier to comprehend than what Kant said, that space and time are a priori forms of intuition. They are not derived from experience, but are inherent structures of the mind that define how we perceive existence. Einstein taught us that we need to think of space and time together, space-time. And Einstein also taught us that space-time is relative. It's all relative. And this makes the idea of now, which is of such supreme importance to the nature of our existence, slightly different for every single person. There is no universal notion of now. Now is in the eye of the beholder, the eye of the observer. And this is just one of the many ways that observation becomes incredibly important in physics. As Einstein himself said, the past, present, and future are only illusions, even if stubborn ones. Part of the reason Einstein said that the past, present, and future are illusions is because time dilates. When I say time dilates, what I mean is the faster you're traveling through space, the slower time moves for you relative to someone that is stationary. It's also true that the closer you are to an increasingly massive object, the slower time moves for you relative to someone that is not close to a massive object. Time dilates because of speed, and time also dilates because of gravity. How strange is that? And so it seems that time is really not what it feels like to us, as each moment passes from an uncertain future into a tangible present, and then on into an unalterable past.
Right. Okay. So that sets the stage for what we're going to be talking about here today. First, we're going to start off with a short clip from Brian Cox. He's going to be talking about time travel. And Brian Cox is a professor of particle physics at the University of Manchester. He also has a PhD in particle physics from the University of Manchester. He has worked extensively on the Large Hadron Collider, and he is the Royal Society Professor for Science Communication. And so Brian Cox is a super real guy.
Do you think time travel will ever be possible?
Not into the past. So into the future, yes. There's a calculation in one of my books with Jeff where we work out, so if you travel at 99.9999999, that's 8 9% the speed of light, to Andromeda, which is 2.5 million light years away, and then turn around and come back again, then for you on the rockets, 100 years will have passed on the round trip journey, but 5 million years will have passed on Earth. So by traveling fast relative to people who are stationary, your clock runs slow relative to that. So you can travel into the future, arbitrarily far into someone else's future.
Yeah. Okay. So you might say in response to that, yeah, okay, whatever, but we can never get even remotely close to the speed of light. And so this time travel that Brian is talking about here doesn't really matter anyway. And I would push back on that. We cannot do that currently But I think you fast forward a few thousand years or maybe a few 100,000 years, and I definitely would not bet against it. And this even brings up UAPs. And at some point, we will definitely do an entire episode on UAPs. That's not what this entire episode is going to be about here today. But with UAPs, you have had consistent reports that these crafts seem to have some sort of electromagnetic field that surrounds them. And that this field is allowing for these crafts to travel much, much faster than, anything that we can do currently. And it seems like, according to reports, that this level of speed for these crafts is happening without propulsion. And it seems like these crafts aren't accelerating through space-time. They are actually warping the space-time around the craft. And so the insane thing is that this actually matches up with theoretical physics. In 1994, there was a physicist named Miguel Alcubierre, and he put together some equations that permit for a warp bubble. And this warp bubble that he was created through physics equations, these equations do not violate the laws of relativity. And while they don't violate the laws of relativity, they do require the usage of something called negative energy density or exotic matter. And science at this point really hardly knows anything at all about negative energy density right now. But that's certainly not to say that we can't ever know anything about this in the future. I would not bet against that. Who knows? Maybe the government already has that, and that's what we're seeing with these UAPs. Or maybe aliens have come to Earth and they are going to show us this technology. It's just not as far-fetched as it might seem. Okay, so the next clip we're going to watch is from Brian Greene talking about time being emergent and not fundamental. Brian Greene is a professor of physics at Columbia. He has a PhD in theoretical physics from Oxford. He is a best-selling author and one of the world's leading experts on string theory. And like Brian Cox, Brian Greene is a super real guy.
What do you mean, beginning of time?
Yeah.
Why would time have a beginning?
Good. And it could be that time is an emergent quality of reality. I'll give you an analogy, boy. What I mean by that is we all know what temperature means intuitively. Something's hot, you feel it. Something's cold, you feel it. Your body understands those concepts. What physics has done is it's gone deeper into the concept of temperature and revealed that it is nothing but the average motion of the particles making up the environment. So if the molecules are moving really quickly, you've got a hot environment. If the molecules are really moving slowly, it's a cold environment. So temperature emerges from the motion of particles. So if you have like one particle, you can't really talk about it being hot or cold because you need a conglomerate. You need an agglomeration of particles to be able to talk about their average motion. And in that sense, temperature is this emergent idea that rests upon more fundamental ideas, the molecules and atoms that make up reality. Maybe that's true of time. Maybe time as we know it is a property that only makes sense in certain environments when there's enough stuff arranged in the right patterns. But fundamentally, maybe there are atoms or molecules of time, which when not arranged in the form that we are familiar with, don't yield time as we know it. Time itself may be a quality of the world that exists here in this environment, but doesn't even apply in other environments that are configured radically differently.
Whoa. That's a heavy one.
Yeah.
Whoa, that is a heavy one. Yeah, I just particularly like this because I think the idea of time being emergent and not fundamental is just one of those things, like many things in physics, that are hard to kind of hold in your head. And comparing that to temperature, and temperature being emergent, not fundamental, emerging from the movement of particles relative to one another, that just helps me kind of understand the relativity of time as well too. So, okay. And then this last one we're going to watch is about a 10-minute video from Sabrina Hassenfelder about dead grandmothers. Sabrina is a research fellow at the Frankfurt Institute of Advanced Studies. She has a PhD in physics from the Frankfurt Institute, and she is one of the world's leading experts on dark matter. And like the two Brians, Sabrina is a, super real gal.
Okay, so let's talk about the physics of dead grandmothers. So I was sitting in a taxi together with a young man, and when I told him I'm a physicist, he said, "Oh, can I ask you a question about quantum mechanics?" And so I thought, well, okay, go ahead. And he said, a shaman told me that my grandmother is still alive because of quantum mechanics. Is this right? I had to pause for a moment and try to understand. And after thinking about this for a while, I came to the conclusion it's not entirely wrong. But the thing is, it's got nothing to do with quantum mechanics. It's actually got something to do with Einstein's theory of special relativity. It's all about the reality of time. It's all about the question whether the present moment, this now which we experience ourselves, whether this is of fundamental importance. There are a lot of things, like those big existential questions about afterlife, that physics can actually tell us something about. My name is Sabrina Hassenfelder. I'm a physicist and research fellow at the Frankfurt Institute for Advanced Studies. And I have a book that's called Existential Physics, A Scientist's Guide to Life's Biggest Questions. Before Einstein, time was this universal parameter. We all shared the same moment of time, the same moment of now that we could all agree on. But then Einstein came and he said, well, it's not that simple. And the major reason for this is that the speed of light is finite and nothing can go faster than the speed of light. It's the same for all observers. And this sounds like a really innocent assumption, but it has a truly fundamental consequence, which is fairly easy to understand, actually. If you ask yourself whether you know if the screen in front of you is actually there right now. Naively, you would say, yes, of course, it's there. I mean, I'm holding it in my hand or I see it directly in front of me. But we just learned that the speed of light is finite and nothing can go faster than the speed of light. So everything that you experience, everything that you see it as it was a tiny little amount of time in the past. So how do you know that anything exists right now? What do you even mean by now? So this is the problem that comes up in Einstein's theory of special relativity. And Einstein tried to construct a notion of now in this new theory, and he failed. So imagine you're looking straight ahead and there's a train going through to your line of sight, say from the left to the right. And on the train, there's your friend, and let's call her Alice. Now, let's also imagine that at the exact moment that Alice, who's standing in the middle of the train, is looking straight at you, there are light flashes going off on both ends of the train. And the question is, did these light flashes happen at the same time? Now, if you want to answer this question looking at the train, that's pretty straightforward. There are those light flashes going off. They both come from sources that are the same distance from you. So of course you see them at the same time. But how does the same thing look from Alice's perspective? The light flashes go off, but while the light travels towards her, she's moving towards one of the light sources and away from the other. So the one path of the light is shorter and the other one is longer. So from Alice's perspective, the light flash from the front of the train arrives earlier than the one from the back. So she would say, no, they did not happen at the same time. And now the important point is that this is relativity. Neither of them is right and neither of them is wrong. They both have an equally valid perspective.
Both have an equally valid perspective. Yeah, so this is just one of the best explanations for relativity that I've ever come across. And that's part of the reason why I wanted to share this video here today, because, sometimes in life I will be studying a particular subject, and after a certain amount of time studying a subject, I feel like I'm at least, kind of smart on a subject. Physics is not like that for me. When it comes to physics, I do not feel smart. I often struggle with truly comprehending the concepts of physics. And for me, this explanation of relativity and the lack of the existence of a universal now, it was just really helpful for me in truly grasping that concept.
And what do we conclude from this? Well, we conclude from this that there is no unambiguous notion to define what happens now. It depends on the observer. So they're both right. And if you follow this logic to its conclusion, then the outcome is that every moment could be now for someone. And that includes all moments in your past, and it also includes all moments in your future. So this impossibility to define one notion of now that we all agree on is called the relativity of simultaneity. And it's super important because it tells us that fundamentally this experience of now that we all share is meaningless. So the mathematical framework that Einstein came up with to make sense of this absence of now and the finiteness of the speed of light and the relativity of simultaneity is that he combined space with time to one common entity, which is called space-time. And more specifically, because the present moment has no fundamental significance.
This present moment has no fundamental significance. I think that's just one of those things that you can just chew on for a long time.
Time exists in the present moment, and it's become known as the block universe. In the block universe, the past, the present, and the future exist in the same way. There's just no way that you can single out one particular time as special. So the past in which your grandma is still alive exists the same way as this present moment.
Okay, so now just to clear things up a little bit, she's now shifting into a totally different but somewhat related topic that's equally as fascinating as what she was just talking about. But it's worth mentioning that what she is about to talk about is not well understood by science. What she has been talking about is very well understood by science and broadly agreed upon. But what she's moving into next, science just still has big question marks on this. So that's just noteworthy.
To look at this idea that people who have sadly deceased do in some sense still exist. And it's because of the way that all the fundamental laws of nature that we know work. They don't destroy information. The only thing that they do is that they rearrange the matter and radiation and everything that's in the universe. They just give you the rules for how to put them in different places with different velocities. But you can apply those rules forward and backward. And this means if you had a really, really good computer, you can, in principle, always find out what happened earlier. So in this sense, information cannot get destroyed. It can, however, become, for practical purposes, impossible to retrieve. There are two cases that physicists have considered where information might get destroyed that have so far not been resolved. One of them is information that falls into a black hole. We don't actually know what happens with it. And the other one is the mysterious measurement process in quantum mechanics, which is also an unresolved problem. So if someone you knew dies, then of course we all know that you can no longer communicate with this person. And that's because the information that made up their personality, it disperses into very subtle correlations in the remains of their body, which become entangled with all the particles around them. And slowly they spread into radiation that disperses throughout the solar system and eventually throughout the entire universe. But this is a very anthropomorphic thing. It's very tied to our own existence. And who knows what's going to happen in 1 billion years or something to the nature of humans. Maybe there'll be some cosmic consciousnesses which will also be spread out, and this information will become accessible again.
Cosmic consciousness spread out, and maybe this information will become accessible again. I mean, you could easily do an entire hour-long episode just on that couple-minute clip there. But just to add a couple things, okay, so matter is neither created nor destroyed. It only changes form. That's the law of the conservation of matter. Probably heard of that before. It's widely agreed upon, but that's matter, not information. And when you get to information conservation, now you are talking about a foundational quantum mechanics concept called unitarity, which says that information is neither created nor destroyed. It just changes form. But the interesting thing about unitarity is that, as she alluded to, science just does not fully understand what is going on here. And Stephen Hawking had this famous black hole information paradox that addresses this directly. That's what she was talking about there. With black holes, it seems like information is lost, but unitarity tells us that information cannot be lost. And so science just doesn't understand what's going on there.
For all we know about the fundamental laws of nature, about Einstein's theories, and about the way that our current theories work, it seems that our existence actually transcends the passage of time. There is something timeless about the information that makes up us and everything else in the universe. And I think that's a really deep spiritual insight that we get directly from studying the foundations of physics. And I have to admit that I personally find it really hard to make intuitive sense of it.
A deep spiritual insight that we get from studying the foundations of physics. And I personally find it really hard to make intuitive sense of it. So Sabrina is an atheist. She does not believe in a God. And so she is saying that she finds this concept really hard to make intuitive sense of from the perspective of an atheist. And I would just like to ask Sabrina the question, have you ever considered God as the intuitive solution to these mysteries of the universe that science hasn't figured out? And I think that in a way, you could define God as the intuitive concepts that fill in these gaps in the biggest mysteries of the universe. And there's actually a term for this. It's called God of the gaps. Maybe you've heard of God of the gaps. And people generally consider God of the gaps to be a weak form of apologetics for the existence of God, because you're basically shrinking God's domain as scientific knowledge expands. But I think that's the wrong way to think about it. It's like ancient humans used to think that lightning was God throwing thunderbolts. And then eventually we learned about atmospheric electricity. And to me, that doesn't shrink God. You're just getting more specific about the manner in which the creator has created this universe. You're learning more about the specifics of the logistics of that creation. On top of that, for every instance that science gives us a specific answer for why something happens, where we previously just said God for that answer, we get additional knowledge to ask deeper questions about the nature of God and the nature of this universe and the nature of God as the creator of this universe that we previously didn't have enough information to even ask those questions. It's like as you're closing the gaps with science, you're also simultaneously allowing for new questions that arise that are increasingly more foundational. And Sabrina here she is getting at this incredibly foundational concept that science doesn't currently fully understand, which is basically, because matter is never destroyed and information is probably never destroyed, is there a path where one day the information that was yourself while you were alive in this meat sack, could that information that dissipates after we die, could it somehow be reconstituted? And she's saying that certainly could be possible. And that's just a pretty crazy thing to hear from a famous genius atheist.
To look at the maths and say, okay, this is how it works. These are the conclusions that we draw from our observations, and the mathematics describes it correctly. It's another thing entirely to make sense of this in your everyday life. But as a physicist, I trust the process of knowledge discovery that comes from using the scientific method. And so I take this seriously.
Okay. So the main point I wanted to make with sharing these three clips is that time is not what it seems to us, despite time being incredibly important to our lived experience. Time is a mirage. The concept of now is completely in the eye of the beholder, yet it never shows up anywhere in our formulas for physics. But then at the same time, now is the realest thing in the world to us. And it is inextricably linked to consciousness. And even though time shows up everywhere in our formulas for physics, science still doesn't fully understand it. But as we've come to understand increasingly more about time over the last century, we are increasingly coming to the conclusion that time is not what it seems. And I just find it helpful to contemplate the existence of God from this perspective and the nature of God from this perspective. At least for me, I find it difficult to imagine what it would be like to exist outside of time. I can kind of try to imagine that, but it's hard for me to hold that concept in my head, everything, everywhere, all at once. And the other main point that I want to make is that, and this directly speaks to skeptics and atheists and agnostics. Skeptics stand on rationality, on logic, on scientific evidence, on proof. Show me the proof. And I get it. I'm a very rational and logical person, and my entire career has been built on rationality and logic and analysis. So I get it. But the issue with having this stance set in stone is that it is based on our perception of how the world works. But your perception is a mirage. Things are not as they seem. The passage of time and the concept of now are perhaps the most fundamental aspects of our existence, and they aren't even real. This sets up for a strange dichotomy. You have time, which is measurable, and it shows up everywhere in our equations, and yet it is a mirage. And you have now, or consciousness, which is immeasurable and found nowhere in our equations, and physics completely ignores it. Yet, it is undeniably the most real thing that we ever experience. And I think that line of thinking leaves the door open for God. Just because you cannot measure God does not mean that God does not exist. In the same way that just because you can measure time does not mean that time does exist. And this line of thinking, this is not a retreat into mysticism. This is actually where physics is pointing us. Measurability does not confer existence. Time might be emergent, or time might be relational, or time might be illusory, even though it's the most measured thing in the world. And unmeasurability does not deny existence. We might just be using the wrong category of measurement tools. It's like trying to weigh a melody. Just because a melody doesn't weigh anything doesn't mean that a melody doesn't exist. It just means that you're using the wrong tool. Okay, that's it. If you like this, hit like and subscribe. If you're looking for the blog, it's in the description. If you're looking for the online community, it's coming soon. If you know somebody that would be interested in Things Hidden, send this to them. I appreciate your time, and I wish you the best.